Alright, so all of this factoring has to have a purpose. And the purpose of it is that we a lot of times need to solve a quadratic equation, which means we need to find the zeros. Now the zeros of a quadratic equation are these points where it crosses your x-axis. So zeros are the exact same thing as x-intercepts when we're talking about quadratic equations. One thing we need to look at is that if I have two numbers here, I've got a and b, and when I multiply them together I am going to get 0 back. One of two things has to happen. Either a has to be equal to 0 or b has to be equal to 0. One of those things has to happen, or both of them could be equal to 0. Well, what we want to look at is, what if I don't just have a single number? What if a was x plus 5? Same thing would happen. So either x plus 5 would have to be equal to 0, or b would have to be equal to 0. Well, on this side, we actually have an equation we could solve now. So subtract 5 from both sides, and you would have x equals -5, or whatever b happens to be would have to equal 0. What if I change it a little bit more? And I have x plus 5 times x minus 3. Well, same setup happens. Either x plus 5 equals 0 or x minus 3 equals 0. Solve each of those and I get x equals -5 or x equals 3. Notice right here, looks like our end result from when we factor. I have two binomials being multiplied together. This is really, really important. So here's going to be our example, and I'll show you the graph of this in just a moment. First thing I would need to do is get it to this setup where I have a quantity times another quantity equal to 0. So basically it's telling me to factor it. I can't pull any common terms out. It doesn't look like it follows a special pattern. So I just have to try to regular factor it. The minus sign means that one is plus and one is minus. My factors of 18 are 1 and 18, 2 and 9, 3 and 6. Well, the ones that are going to get me to the 3 are the 3 and the 6. And it's going to be plus 6 and minus 3. Foil that out to check it, which it does turn out right. I've already checked it. But now, this is a little bit different because we're asked to solve it. So we're actually asked to find the x values. Where right now, I'm at that point where I have a times b is equal to 0. So I can take my factors and set each one of them equal to 0, and that will allow me to find the x-intercept, or the zeros. So I get x equals -6, and I get x equals 3. Well, now when I look at the graph of this, what that means is that my graph is going to cross down here at -6 and right up here at 3. And it's going to come through like that. So when you're asked to solve it, you are asked to find the values of x. One critical feature is we always have to have it equal to 0. So here's a couple examples. The first one, we have 2x squared minus 17x plus 45 equals 3x minus 5. Now as you look at this, I hope you notice that it's not set equal to 0, so we have to do that first. So I'm going to go ahead and subtract 3x from both sides, and I'm going to add 5 to both sides. So I will be left with 2x squared minus 20x plus 50 is equal to 0. So now I've got it set equal to that 0. Second thing I need to do is factor it. Well, as I look at this, I notice I can pull a 2 out. So I'm going to put a 2 out in front and be left with x squared minus 10x plus 25 is equal to 0. Oh, and when that happened, I ended up getting a perfect square here on the back and a perfect square on the front. So it might be a perfect square trinomial. But let's say you didn't notice that. You can still factor this out like normal. So since I only have an x squared there, I'm going to have x and x. The plus sign by the 25 means they match. This one means they match as negative, so I'm going to have minus minus. My factors of 25, 1 and 25, or 5 and 5. Well, to get to the 10, I'm going to need the 5 and the 5. So check this by foiling it, and I'm going to get x squared minus 5x plus 25. And I do end up getting what I need when I simplify that down. I get x squared minus 10x plus 25, and I still have that 2 out in front. So I've gotten it factored right now, but the direction said to solve it. Since this is equal to 0, I've got several things going on here. I've got a 2, I've got an x minus 5, and I've got an x minus 5. So what I have to do is I have to set each one of these equal to 0. Well, if I take my first one, 2 equals 0, that's not a true statement. So that one we get rid of. Doesn't work out. Then I take my second one, x minus 5 equals 0. Solve that and I end up with x equals 5. Take my third one, which is x minus 5 equals 0. Solve that and I get x equals 5. Well, now since these were the exact same thing, we only have to write it once. And we get our answer of x equals 5. Now to check it, what you can do is plug it back up into your equation and you should get the exact same thing. It should work out. Okay, let's take a look at this second one. I can't pull anything out. It's already set equal to 0. It's not perfect, so I think I just have to regular factor this one. I start up here. Now this one's a little bit trickier because to get 6x squared, I could do 1x and 6x, or I could do 2x and 3x. So we've just got to guess and hope we get it right. I'm going to go ahead and use the 2x and the 3x for my first try. Then I look at my plus sign at the end. It tells me they match. This one tells me they match as minuses, so I'm going to have minus minus. Nice thing is that my only factors are 1 and 5. So I'm going to go ahead and plug my 1 and 5 in here, and I'm going to keep my fingers crossed that it works. So when we FOIL this out, I'm going to have 6x squared minus 10x minus 3x plus 5, and I can see it doesn't work because 10 and 3 don't give me the 9. Okay, so that one didn't work. I'm going to flip-flop my 1 and my 5 around. So I'm going to do 2x minus 5 and 3x minus 1. Hopefully this time it'll work. So I've got 6x squared minus 2x minus 15x plus 5. I can see that's not going to give me my 9x that I need. So that one didn't work. Well, now, since 1 and 5 were our only factors of 5, I need to go back up here and rethink my 2 and my 3. I'm going to try 1 and 6 now instead. So I'm going to do x minus 1 and 6x minus 5 and hope this time it works. So I'll have 6x squared minus 5x minus 6x plus 5, and that's not going to give me the minus 9. So we're going to have to do x minus 5 and 6x minus 1 and hope that it works this time. So we're going to have 6x squared minus 1x minus 30x plus 5. Well, I can see that's not going to give me my 9 either. So now, if we look at this, when I had my 2 and my 3, I tried the 2 with the 1 and the 3 with the 5, and then I tried with the 2 and the 5 and the 3 and the 1. So I knew it wasn't 2 and 3. The 6 and the 1, x, I tried with 1 and 5, and then I flipped them and tried it with 5 and 1, and that didn't work out. So I've tried out all my possibilities, and it didn't work out. So this one is not factorable. And you might be thinking, so we just did all that work for nothing? Well, you've got to go through all 4 of them before you can come to the conclusion that it's not factorable. That will happen sometimes. Okay, give these 2 a shot. So go ahead and pause the video and see if you can factor them. Okay, hopefully you noticed on this first one that you could pull a 5 out and be left with x squared minus 4. Then that followed the pattern of the difference of 2 squares, or you could factor it normally, and it factors into 5 times x plus 2 times x minus 2. Now when you set each one of these quantities equal to 0, you get 5 equals 0, x plus 2 equals 0, x minus 2 equals 0. Well, the 5 equals 0 doesn't make sense. It's not true, so cross that one out. Then the x plus 2, when you solve that, subtract 2 from both sides and you get x equals negative 2. Your next one, the x minus 2, add 2 to both sides and you're left with x equals 2. Okay, the second one. Hopefully you noticed that you could pull the 3 out, and then you would factor it down to the 2x plus 3 and the x plus 1. Set each of these quantities equal to 0, so 0 equals 3, 2x plus 3 equals 0, and x plus 1 equals 0. Now when you solve the first one, you have to subtract the 3 off and then divide by the 2. So you end up with x equals negative 3 over 2. And then the second one, subtract the 1 off and you get x equals negative 1. Both of these we factored earlier, so all we did was we extended it one more step and solved them. Okay, so here's what I want you to do. These two problems, and bring them to class with you.